So today's video is prerequisite skills that you will need for the similar triangles unit. So they are concepts that you learned in grade 9, but we're just going to review them right now. So right now we're going to state the relationship between some angles. Okay, so if you have a triangle, all the interior angles, so the shaded regions, they are all going to add up to 180 degrees. If you have two lines that are intersecting, the opposite angles are going to be equal. Okay, and I'm just going to show you which ones I'm talking about. So this angle here is equal to this angle, and this angle right over here is equal to its opposite angle. Okay, then we also have alternate angles, which we also call the Z rule. And when you create a Z rule out of parallel lines and an intersecting line, the insides of the zigzags are equal to each other. Okay, so they're equal angles. And that Z doesn't have to be a normal Z. It could also be a backwards Z, like it is in the second scenario. So again, inside the zigzags, the angles are equal. Okay, then we also have our corresponding angles, and again, that's on parallel lines, and this is also called your F pattern. Okay, so if I create an F out of my parallel lines, inside the F, those two angles are equal to each other. And again, your F doesn't have to be in the normal position. It can be backwards, like it is over here. It can be flipped upside down, like it is here. But it's the insides of the F's that are always equal to each other. Okay, so we have equal angles. So again, for your Z and F pattern, or your alternate and corresponding angles, you need parallel lines, and then one line that kind of cuts both of them. Then we also have co-interior angles, which again are on parallel lines, and this one's a little different from the other ones, just because when you create a C out of your parallel lines, the two angles created in the C, they are not equal. They actually add up to 180 degrees. So add up to 180 degrees. So don't confuse the co-interior angles with the other ones, because the co-interior angles are not equal to each other. They add up to 180. Okay, so we're going to do a little example using pretty much all of those properties. Okay, we have a triangle, actually two triangles right here, and we're going to find each unknown angle. So we're going to start with angle A, okay, which is right over here. I have parallel lines right here, which means I can use my F pattern, my Z pattern if I find it. And I notice I have a backwards F right over here, which means this angle A is also equal to 40 degrees, the insides of the F. Okay, so that is 40 degrees, and that's because we have corresponding angles. Now when we try to find angle B, it's not going to be as direct, but what I notice in this little triangle is that we have an isosceles triangle, because it's telling us that these two sides are equal. So if I have an isosceles triangle, that means this angle here is also 40 degrees. Now I can use my sum of interior angles of a triangle. I know they all have to add up to 180 degrees, which means B is going to equal what's left over. So 180 minus the 40 minus the second 40. And when I subtract them, I have 100 degrees left for angle B. Okay, so angle B is 100 degrees, sum of triangle. Okay, now when we look at C, I'm glad I put that 40 degrees there, because I have another F pattern right here with my parallel lines. And now C is equal to this 40 degrees on the right. 40 degrees, and I'm just going to write for corresponding. Okay, and our last one is angle E. And right in here, I have co-interior angles. And the co-interior angles are not equal, but E plus C should equal 180 degrees, which means E is going to be 180 minus that 40 degrees, which gives me 140 degrees. So that's my co-interior. Okay, so sometimes you have to find extra angles to help you find the missing information. Okay, so to recap, all of your angles in a triangle add up to 180. When you have parallel lines, you have your F pattern, your Z pattern, and your C pattern. So your alternate and corresponding angles are equal to each other, while the co-interior angles have to add up to 180. The next thing we're going to look at is how to solve proportions, but before we get to that, we have to know what a proportion is. And it's just a statement that two ratios or rates are equal to each other. You'll recognize ratios as two fractions that are set equal to each other, and you're going to have an unknown either in the numerator or denominator. Okay, and you can only have one unknown, so one variable. It can occur in multiple places, but it can only be one variable you can't actually solve. But the way you're going to solve is by cross multiplying. Okay, so all that means, if I look at this example, 3 over 5 equals a over 15, I'm going to multiply the 15, or the 5, by the a, so that's 5 times a, and then I'm going to multiply the other cross, 3 times 15. So each cross is going to be on one side of the equal sign. So now we simplify a little bit. 5a equals 3 times 15 is 45. And now it's the most basic linear equation we have. So I'm going to divide both sides by 5, and that's going to give me an a value of 9. Okay, let's try another one. Okay, so I'm going to cross multiply. So I have x times 5, or 5x, equals the 4 times the 7, which is 28. And then I'm going to divide both sides by 5 to isolate 4x. And when I do that, I get x is equal to 5.6. Okay, make sure though for a proportion you don't have anything else being added or subtracted to your fraction. It has to be one fraction equals another fraction. Okay, let's try a few more complicated examples. So here the only difference is that we don't just have the variable n, it's 2n, but the process is identical. I'm going to cross multiply, and I'm going to show it the longer way. So I'm going to do 15 times 2n is equal to 6 times 25. So 15 times 2n is going to be 30n, and then 6 times 25 is going to be 150. Now I can divide both sides by 30, and I get an n value of 5. Okay. Now if we look at the next one, you're going to notice that I don't have just x or 2x, it's x plus 1. In this case, writing your proportion or your cross multiplying out the long way, like I did in the previous example, is really important because you're going to need distributive property. Okay, so I'm going to do 10 times x plus 1, and notice I put that x plus 1 in brackets, that's super important, is equal to 15 times 6. Now, because I have brackets, I need to distribute that x in. And I get 10x plus 10 is equal to 15 times 6, which is 90. Once I get rid of my fraction by cross multiplying, I can solve my linear equation. So I bring the 10 over so that it becomes 90 minus 10, which is 80, and then I divide out my 10 to isolate for x, so that I get an x value of 8. I want you to pause the video, and I want you to try that next example on your own. Okay, so when you solve the next one, we should have 12 times x plus 2 equals 2 times 30, so that's second cross. Now we have to distribute the 12 in to get 12x plus 24 equals 60, and then we solve the linear equation. So I brought the 24 over and it became subtraction. That's how I got this 36, and then I divided out the 12 to get x equals 3. Okay, just like solving linear equations, you can check your work here by doing a left side, right side check if you're not sure or if you're not confident in your answer. Okay, now sometimes you're going to get examples where you're actually going to have your variable in two different locations. It's okay that you have two variables in different locations because it's the same one. So in this first scenario, we have w's, but they're in two different places. If I had a w and an x, that would be a problem. But I'm just going to do the same thing, and I'm going to cross multiply and see where that takes me. So I have 10 times w equals 6 times w plus 4. And then I'm going to have to distribute that 6 in. Okay, so right now you guys have the knowledge to solve this. You don't really need to watch. You can go right ahead, but I'm going to work through it. So I have 6w plus 6 times 4 is 24. Now I have variables on both sides. All that means is I need to bring that 6w to the other side to join the 10, so that I have 10w minus 6w equals 24. Collect my like terms, and then divide out the 4. Okay, so this part should look familiar from grade 9. It's nothing new. Okay. I want you to try the next one on your own, and then come back to the video to check your work. Alright, so when you cross multiply your first line, which is the most important line, you should have 3 times 5x equals 10 times x plus 5. If you had it the other way, so you had the 10 times x plus 5 on the left and the 3 times 5x on the right, not a big deal, you should still get the same answer. Okay, now I distributed that 10 into my bracket to get the 10x plus 50, and then I brought the 10 to the other side. And again, make sure you're careful and you change the sign, or else you're going to get the wrong answer. So now I had 5x equals 50, divided out my 5, and I was left with x equals 10. Okay, now the next one's quite interesting. Okay, I have x's in two different spots, not a big deal at first. When I cross multiply though, something interesting happens. I multiply x plus 3 by x minus 5, and that's going to give me negative 1 times 12. What's interesting here is now I have two binomials, which means I have to FOIL. Now when I FOIL two binomials, I'm going to end up with a quadratic equation, which takes us back to the previous unit. So I'm going to FOIL here. Okay, so that I get x squared minus 5x plus 3x minus 15 equals negative 12. Now because this is quadratic, I'm not going to isolate for x, because the way we solve is by bringing everything to one side and then either factoring or doing quadratic formula. So I'm going to bring that negative 12 over, and I'm going to collect my like terms. So I have x squared minus 2x, and when I bring that negative 12 over, it becomes positive 12. So again, I'm going to collect my like terms once more, and I have this. Now it's a simple trinomial, so I'm not going to bother with quadratic formula. I'm going to find two numbers that give me a product of negative 3 and a sum of negative 2. And those two magic numbers in this case would be negative 3 and 1. So now I factor. X minus 3, x plus 1 equals 0, which means I have two different solutions for this proportion. I have x equals 3, and I have x equals negative 1. So whenever you're cross-multiplying or whenever you're doing an equation and it becomes quadratic, we have to remember the skills we learned in the previous 3 units, where to solve a quadratic, you have to find either the factored form or use quadratic formula to find those x-intercepts. Okay, now we're going to look at how to prove that triangles are congruent. Now, congruent just means that the triangles are identical. All the sides are equal and all the angles are equal. But when you're given a triangle, you're not necessarily given all of the information. You're not going to be given all of the sides and all of the angles of both triangles. So to prove it, we have 5 different ways we can do that. Okay, the first way is you're given all 3 sides of one triangle, and they're equal to all 3 sides of the other triangle. Okay, and I'm just going to show that with that tick mark notation. So this side is equal to this side is equal to that side, that's equal to that. I'm not given anything about angles, but I know all my 3 sides are equal. So my 2 triangles are congruent. That's one condition, or that's one way to prove it. Another way is if you have two angles and the contained side. So that's ASA, angle, side, angle. So we can see here this angle is equal to this angle. This side is equal to this side. And this angle is equal to that angle. You'll notice that the side that is equal is sandwiched between the two angles. That's why it's called the contained side. Okay. We also have angle, angle, side. Okay. So that's two angles and a non-contained side. So that would look like this. This angle is equal to this angle. This one might be equal to that one. And then this uncontained side is equal to that uncontained side. Okay, so angle, angle, then side. Okay, we also have side, angle, side. So two sides are equal in the two triangles, and the angle contained between the sides are equal. So that would look something like this. This side equals this one. This angle equals this one. And this side equals that one. So the angle that is equal, it's sandwiched between the two sides. And the last one is for a right triangle. So if in a right triangle, if the hypotenuse and another side is equal to the hypotenuse and another side of the other triangle, then they're equal. The reason being is that if it's a right triangle, that means they both have a right angle. So they already share an angle, and then the other one is they have to share two other sides. So for example, the hypotenuse is equal to this hypotenuse, and then this side is equal to this side. Or it could have been the hypotenuse and the other side, or it could have been the two non-hypotenuse sides that were equal to each other. And this one's kind of similar to the side, angle, side congruency from the previous example. So now we're going to do a few examples where we're given a pair of triangles and we have to see if they're congruent, and if they are, what congruence sufficiency condition applies. So if we look at the first set of triangles, I notice that we have two sides that are both 6, two that are both 8, and two that are both 12. So we have 3 equal sides, so that would be the side, side, side sufficiency. So now when we state our congruent statement, we have to make sure we're going in the same order of the sides to make sure that our angles kind of match. So if I start at A, I'm going to start at D here and then go in that direction for both of them. So I have angle or triangle A, B, C is congruent to triangle D, E, F. Okay, and notice the symbol in the middle right over here. It's an equal sign with a squiggle on top, and that just means congruent to. Okay, let's try an example where they actually give us a set of congruent triangles and we have to solve for some unknowns. So triangle NPQ is congruent to triangle RST. State the values of x, y, z. Before we actually do that, let's go ahead and change this to an N and this to a Q so that we actually solve, so that our triangle actually matches. Okay, I like to use a highlighter here, and I like to see which sides are the matching ones. So just by looking at it, I think this side and this side match. The 7 matches with this, and then the longest side will match with this longest side. And when I do that, I know which sides should equal. My green lines should equal, which means x should equal 8. My red lines should equal, so y should equal 5. And if I had to figure out what NP was, well, I would know that it has to match the other blue line, which is 7. So I can go ahead right now and state that x is equal to 8 centimeters, y is equal to 5 centimeters, and now I need to find an angle. So this angle Z is formed by my blue and red line, which means it has to equal angle T. Okay, so Z equals angle T. Angle T, I have to do a little calculations to solve for it. So I know my other two angles, which means angle T is going to be 180 minus 45 minus 50, which gives us 85 degrees. So that's what angle T is equal to, which means Z is equal to 85 degrees. So congruent triangles are just the same. You're just matching some things up, and sometimes you'll have a little calculation just related to your angle if needed. Okay, let's try another example. Okay, triangle EFG is congruent to HJK. State the values of X, Y, and Z. Okay, I actually want you to pause this video, and I want you to try it on your own, and then take it up after. Alright, so the first thing I'm going to do is highlight some matching sides. Okay, it looks like EF is going to match HJ. FG is going to match JK. And EG matches HK. So this second triangle on the right is just kind of rotated, but then you'd get the same thing. So let's see if there's some easy things I can solve for first. Well, I know my red lines match, which means Y should equal 6 centimeters. I know my blue lines match, which means Z should equal 9.6 centimeters. And now I need to solve for angle X, which is right over here between the blue and the green. I don't have that angle here. I don't have angle K, which means I might have to do a little bit more matching. So I know between the red and the green lines, that's 80 degrees. So this is also 80. Between the blue and the red, that's 62, which means in here, it's also 62. So I can solve by X by just subtracting 80 and 62 from 180. X equals 180 minus 80 minus 62. So X is equal to 38 degrees. Okay, and that would be it. Okay, last example. Show that these triangles are congruent. State the congruency statement, the sufficiency condition, and state all evidence. Okay, so I notice I have parallel lines. Okay, I don't have any side lengths, which means I can't use a side sufficiency condition. It must be angle related. So I have to think of those pattern rules. I'm going to use a highlighter right here. I have a Z pattern right over here, which means angle D and angle B must be equal to each other. Okay, so this angle must equal that angle. And I'm going to write that out as proof, as evidence. Angle B equals angle D. I also have another Z pattern, or alternate angle pattern, right here. So even though I don't know the angle measurements, I know that angle A is equal to angle C, which means this angle here and this angle here should also equal. And that's also because of the opposite rule, opposite angles rule. Now, I can't just say angle E equals angle E because they are two different angles, like two different locations. So we have to use that 3 vertice notation. Okay, make sure the angle we want, so angle E is the contained letter. So if I want to state this angle right here, I'd write A, E, B, or you can write it as B, E, A. If I want to state this angle, I would write D, E, C, or C, E, D as the angle. Okay, so I'm going to write A, E, B is equal to angle D, E, C. Okay, so that's my angle condition, and then I can state my congruency statement. So triangle ABE is congruent to triangle CDE. And now we can determine our values for X, Y, and Z like we did before. Well, I can see right here with my Z pattern, I already said that these two angles are equal. So I can state that Y is equal to 40 degrees right away. I can also state that Z is equal to 100 degrees because of that opposite rule. And now all I have is X. Okay, and it looks like these two triangles were just rotated. So this triangle right here, if I just rotate it in this direction, it'll match, which means this 5.2 matches that x. Just like this base would match this base, and this diagonal would match this one if I just rotated it like 180 degrees. So our last one, x equals 5.2 centimeters. And that's it for congruency. So congruency, same sides, same angles. Okay, last thing, Pythagorean theorem, everyone's favorite. A squared plus b squared equals c squared. So before we get to that, I'm just going to look at this right triangle. Remember, Pythagorean theorem only for right triangles. And I'm going to label the side opposite the right angle is called your hypotenuse. And this is always, always, always the longest side, and it's always, always c. A and B, these are just called the legs of your triangle, so the other shorter sides. So let's use Pythagorean theorem to solve for some sides. Okay, so here I'm solving for my hypotenuse. So E is acting like the C. I can label the 3 as A and the 4 as B. So in this case, I'm using the typical A squared plus B squared equals C squared, but I'm just going to write it as C squared equals A squared plus B squared, because it's the hypotenuse I'm looking for. So now I'm going to replace. E squared equals, my A value is 3, my B value is 4. And now I simplify. E squared equals, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. And now, how do we get rid of an exponent? We square root both sides. Now I know in quadratics I said whenever you take the square root of a number, it's the positive and the negative version. However, because we are dealing with a side length, it's always going to be the positive version. Okay, because I can't have a negative hypotenuse. So in this case, E is equal to 5 centimeters. Okay, now what happens when we're looking for A or B? So we're looking for one of the legs. So the 15 is my hypotenuse. That's going to be my C. I'm going to call this A, and we can say the leg that I'm looking for is B. And what we do here is we just use a rearranged formula. So usually this is your Pythagorean theorem, but if I'm looking for a leg, I just need to bring A squared to the other side to isolate for one of the legs. So this would be the formula you want to use when you're looking for A or B. Okay, if you're looking for the hypotenuse, you want to use your classic one, but when you're not, you can use this rearranged one. Or you can use the classic one and rearrange it yourself every time. Not a big deal. So here I'm going to put E squared is equal to 15 squared minus 9 squared. 15 squared is equal to 225. 9 squared is equal to 81. And when we subtract those, we get 144. And when I square root that, I get an E value of 12 centimeters. Okay, so again, this is for the hypotenuse. And then you can use this one when you're looking for a leg. Okay, but again, you don't have to use this rearranged one. You can use the classic and rearrange it yourself. You'll know you did something wrong if you end up with a negative number and you can't square root it.